Hello everyone, welcome to my channel. Let's learn computer science.
Hey everyone, welcome to day 17 of Python tutorial. In today's video, you'll learn about abstract data types and specifically about stacks as part of abstract data types. So we'll have an overview of what abstract data types are, and along with that overview of stacks as abstract data types. Also, we'll understand LIFO principle of stacks. And how do we implement stacks using lists in Python, along with stack operations, including push and pop? So let's start. First of all, let's understand what abstract data types are. So basically, abstract data types, this is a theoretical concept in computer science, which means we create some data types or data structures along with what operations can be performed on these data structures, without specifying how they are implemented. And that is the reason they are called abstract, because it gives an implementation independent view. You don't need to go into details of how it is implemented. All you need to do is define the data structures along with the operations that you want to perform on these data types. So here you define the behavior with the help of some attributes and of course some functions as part of the operations that can be performed on these data types. Some examples of ADTs include stacks, queues, trees, and graphs, etc. Right? So they have their own set of operations defined, and of course, they have their own characteristics. Now let's understand what stacks are as an abstract data type. So basically, stack is a linear data structure which follows the LIFO principle, which is last in, first out. That means the elements, they are inserted and removed from the same end, which is known as the top of the stack. And the last element inserted is the first one to be popped out. Okay, so the operations that we perform on stacks are push and pop. Push means inserting an element into the stack, and pop means removing an element from the top of the stack. So stacks, they work on LIFO principle. That is a thing that you all need to understand and remember. So what is LIFO? LIFO is, as the name suggests, last in, first out. So the element that is added last is the element which will be removed first, right? So just to understand the principle, so if you think about a stack of plates, so if you have created a stack of plates, so the last plate which is on the top of the stack, that is the first one to be removed from that stack. You will be removing the element which is placed at the top of the stack. In Python, we implement stacks using lists. So how do we do that? Very simple. So if you look at this example, so initialize the stack, right? As an empty stack, you can initialize it. You can use append function of lists to add an element, and to remove an element, you can use pop function, right? So if you look at this example, so I have initialized a stack as an empty stack, right? As a list, of course. And then I have added an element A, then I have added another element B, I have added another element C, and I have printed the stack. So if you look at the output, so initial stack is A, B, C. So I have inserted 3 elements. And now if I want to pop, if I want to remove the element, so when I remove first element using print stack.pop, then it is C which is removed, right? So last element which is inserted is going to be the first element that is removed. Second time when I have removed an element, then it is B and then it is A. And if I print the stack, then after removal of all these 3 elements, my stack is empty again. Yeah. So that is how we implement stacks using lists in Python. There are basically two operations that we can perform on stacks. One is push and another one is pop. Push means adding an element on top of the stack, and pop means removing the element from the top of the stack. So I'll take you to Python IDLE and I'll show you how do we implement a stack. So now let's see how do we implement stacks in Python using lists. So for that, I'm going to create, first of all, an empty stack. Okay. So I have initialized an empty stack, name is stack only. Now I'm going to create one function to push an element, another function to pop an element, and one more function to display. So let's create function push to push an element, to insert an element, right? Now, for that, of course, you need to take element from the user. But along with that, in reality, in real life, you have to have some maximum number of elements, some limit on maximum number of elements that can be inserted into your stack. If you look at practically in Python, of course, your stacks, they are flexible, dynamic in nature. You can add as many elements as you want. However, if you want to put a limit, so you can define a maximum length. So you can say max length is equals to, let's say, maximum you can have 10 elements in your stack, right? So this will help me to check for an overflow. So once you reach your maximum limit, you can check for the overflow, that you do not exceed the maximum length. So first thing that I'm going to do is I'm going to check if my uh, length of my stack is beyond the maximum length, which is acceptable. So length of stack, if reaches this, you can simply compare it with 10 also, but I just, for reference, I have written this, right? So you can, instead max length, you can simply write 10 also. So if reaches this, then I am going to print a message mentioning that maximum limit has reached. So I can simply write overflow. Insertion not possible. Right? So a simple method, anything you can write. Otherwise, if not, then you can write, then you can ask user to enter an element, right? You can ask user for the element. To be inserted, right? So you can ask user for the element and you can insert that element. You can append that element in your stack. So stack dot append element, which you have taken from user, you are going to append that. So that's my push function. Now I'm coming out of this and I'm going to define pop function as well. Now for pop, you need to check whether your stack is empty or it has element. If empty, of course, you don't have anything to pop. So for that, I can check if the same thing, this, but I'm going to check for whether it is 0. If it is 0, if the length of my stack is 0, that means I don't have any elements to pop. So I can simply write underflow instead of overflow. I can print underflow. So I'm writing here underflow, deletion not possible, right? So this is my underflow check. Else what I'm going to do, I'm going to take out the topmost element. For that, what I'm going to do, I'm going to print stack dot. So inbuilt function pop I'm going to use for removal of the topmost element, right? Now my pop function is also created. Now I'm going to define a show function using which I will display the elements of stacks, where I'm simply printing my stack, right? So whatever elements are there in the stack will be printed. Now what? I have to call these elements. So for that, I can create a loop. While true, I'm asking user to enter their choices. So print, enter your choice. So as part of choice, user can enter 1 to push an element, 2 to pop, 3 to display or show stack, and 4 to exit, right? So these are some choices that user can use, and I'm taking this as choice equals to input, and I'm taking it as integer, right? So I'm taking it as integer. Now, if choice is equals to 1, so if user enters 1, then what I'm going to do, I'm going to call push function, else if user is entering choice spellings, I'm correcting it. So if user is entering 2 as choice, then I'm calling pop, else if user is entering 3 as choice, then I'm going to execute show. Just remember, if here it is in capitals, then I have to write here function name as capitals here as well, right? Last, I can write another thing for exit. So for exit, I can write if choice is equals to 4, then I'm just coming out of my loop. Last but not least, else if user is not entering 1, 2, 3, or 4, then I am displaying a message, print wrong choice. And then I can write same message, this one. Enter your choice, 1 for push, 2 for pop, 3 for show, and 4 for exit, and that's it. Now I'm going to run this program to see the output. So it's asking enter your choice, 1 to push, 2 to pop, 3 to show, and 4 to exit. So first of all, I'll show my stack. It is empty initially, right? It's again asking for my choice. Now I'll try to pop. It should show me underflow statement because right now my stack is empty. So 2, yes, it has shown me underflow, deletion not possible as there is no element as at the moment. Now I'm going to enter some elements in my stack. So one is to push. So element I'm going to enter is A, then again I'm pushing. Next element is B, again I'm pushing. Next element is C, again I'm pushing another element. So next element to be inserted is D. I'll just show you my stack. So it is A, B, C, D as of now, right? So again, it's asking for my choice. I will now try to reach the maximum limit, which is 10. So I'll enter another element. I'll enter some random elements. right? To reach the maximum limit of my stack, which is 10, right? Then again, then again, and here it is telling me overflow insertion not possible. Now why? I'll just show you. So maximum elements entered are already 10. So A, B, C, D, E, F, G, H, I, J. These are the elements which are entered. I cannot enter any more elements, but I can now pop. So if I choose 2 as my choice, so the topmost element is popped out, which is J. So if I show you my list now, so last element is popped. Again, if I choose 2 as my choice, it will again pop out the last element entered. So again, I'll show you. So this is my list now, right? So that is how we implement stacks in Python. And now it is assessment time. There are few questions for you. Try to pause the video, answer these questions, and of course, in the end, I'm going to display the answer key, right? All the best. And here is the answer key. Compare your answers. Thank you. Bye-bye. See you in the next video.